Bismillahirrahmanirrahim. Let's say this look at the relative maximum and relative minimum. Last time we said that these terminologies or the definition of relative maximum or relative minimum, it's just finding the highest value or the lowest value among just a small interval of the domain. And for the relative maximum, we said that f of x greater than or x sub 0 for all x belongs to some open interval I in the domain of the function, we said this will be relative minimum, or I'm sorry, maximum. And if f of 0 less than or equal to f of x for all x belongs to some open interval in the domain, then we will have relative minimum. And also we said that the relative maximum and relative minimum are just located at some point for the critical point. Critical point. And we said that for the critical points, either the derivative of x equal to 0 and solve for x, or f is not differentiable. If the derivative equal to 0, then the solution for that equation will be the critical point, and that type of critical point we call it stationary point. In the last part, we solved maybe a couple of examples. We say, or for example, how to find the critical point. And we say that to find the critical point, we have to find the derivative and make it equal to 0 if it can be, or if the function is not differentiable, then we will have some critical points which are not stationary points. For this part, now we are going to test these critical points. These will be relative minimum or relative maximum. We need to determine whether the points are relative maximum or relative minimum. And to find the type of the extremum for this point, we have to test. The first one is called the first derivative test. Start with the theorem, the first one. Well, this is the first derivative test. And the statement says that suppose that f is continuous at a critical point x0. Then number 1 or A, f prime of x greater than 0 on the left. Of x0 and less than 0 on the right. Means I will have something like this is x0 and the derivative is greater than on the left and less than on the right. When the derivative is greater than means it is moving upward, it is increasing. And if it is less than 0, it is going or decreasing. So we'll have something like peak of mountain or a hill. In this case, the function f will have a relative maximum. Then f has a relative maximum at x sub 0. Now, if we reverse second case, if f prime is less than 0 on the left, at x0, f of x. And f prime x greater than 0 on the right. Then it has a relative minimum. And it takes this shape of 0. And the function is going down on the left and going up on the right. So it takes this shape, concave up. This point will be relative minimum. So the function f has a relative minimum at x equal to 0. For the third case, f prime has the same sign. On the left and right. Of x0. It means that the derivative is not changing the sign. It is not changing the sign before and after the critical point. In this case, there is f has or doesn't have a relative maximum at x sub 0. Then f does not have a relative maximum. At x sub 0. So we have three cases. Either the derivative will be going down before and up after. In that case, we will have relative minimum, or going up before the critical point and then down after the critical point. In that case, we will have relative maximum. And the third case, when the sign of the derivative is not changing before and after the critical point. In that case, the function doesn't have a critical point at that given point. Now to explain this with one example, let's find this example. Find the critical point or find the point of relative maximum or minimum of the curve. Let's find the point of relative maximum or minimum, if any. Of the curve. Number one, f of x equal to x to power 5 minus 5 x to power 4 plus 5x to power 3 minus 15. Now to find the point of the relative maximum or relative minimum, first of all, we have to find the critical points. So step number one, find the critical point, CB, critical point. It means that I have to find the derivative. To find the critical point, we have to find the derivative of the function. That will be 5x to power 4 minus 20x to power 3 plus 15x square minus 0. The derivative of the constant is equal to 0. Now to find the critical point, make this equal to 0 and solve for x. I will take 5x as a common, or 5x squared as a common factor. Then I will have x squared minus 4x plus 3 equal to 0. Or it is 5x squared multiplied by x minus 3 multiplied by x minus 1 by factoring equal to 0. This means the critical point will be x equal to 0 for the first one, x equal to 3, and x equal to 1. These are the critical points. Now I need to check, does the function f have a relative maximum at x equal to 0 or not, or relative minimum at x equal to 3 or x equal to 1? So to check this, I have to apply the first derivative test to see. We need to check the sign of the derivative, step number 2. Let's check the sign of the derivative before and after each one of the critical points. I have 3 critical points for this function: 0, 1, and 3. For each one of them, just to check the sign, I will choose something called the testing point. Less than 0, I will choose minus 1 as a testing point for the derivative. Between 0 and 1, I will take 1/2. 1 and 3, 2. Greater than 3, I will choose 4. We need to just check the sign of the derivative. No need to see the value, I need just to check the sign. Now, if x equal to minus 1, let's go to the derivative, to this one. Replace x by minus 1. Will it be positive or negative? This 5 multiplied by 1, minus 1 with minus 3 is minus 4 times minus 2. I will have positive sign. Less than 0, it is positive. Replace x by minus 1 in the derivative. X equal to minus 1. Put it there in the derivative. We find f prime of minus 1. You will have positive number. Now for the f of 1/2. Replace 1/2 in the derivative, 1/2. And check the sign. This is negative, negative, positive. So I will have positive also. So the derivative is positive there. Now replace x by 2. If you replace x by 2 in the derivative, we have something negative. So the sign of the derivative is negative. F prime of 4, you will have something positive. If you check, replace x by 4, you will get positive value. So the sign of the derivative after 3 is positive. Again, we just substituted x by the testing points in the derivative. Replace x by -1 in the first case and check the sign of the derivative, then 1/2, then f prime of 2, then replace it by 4 just to check the sign of the derivative. Now you can see before 0, it is positive. After 0, positive. No change in the sign of the derivative, which means at x equal to 0, the function f doesn't have relative maximum or relative minimum because the sign of the derivative is not changing. Around the number 1, we have positive then negative. It is relative maximum, then negative and positive relative minimum. So we can say at x equal to 0, f of x or f, only the function f, doesn't have relative maximum. Now at x equal to 1, f has a relative maximum. And that relative maximum will be f of 1. Just find that value, that will be the relative maximum at x equal to 1. At x equal to 3, f has a relative minimum. And that relative minimum is equal to f of 3. Just replace x by 1. That will give you the value of the relative maximum. And if we replace x by 3, we will have the relative minimum. So at x equal to 1, the function f has a relative maximum. At x equal to 3, f has a relative minimum. And at x equal to 0, f doesn't have any extremum. There is no maximum or minimum at that one. Let's take another example. Number 2. F of x equal to x squared minus 4x plus 1. Let's find the critical point first. Step number 1. Find the critical point. That we need to find the derivative. It is 2x minus 4. Make it equal to 0. This will give you x equal to 2. So the critical point is x equal to 2. Now, step number 2, check the sign. Of the derivative. I have only one critical point in this case, these two. So I can take a number less than 2, I can take 0. Bigger than 2, I will take a 3. Now f of or f prime of 0 is equal to, this is my derivative. Replace x by 0, it is minus 4. So the sign is negative. F prime of x is negative in the interval less than 2. If we replace x by 3, f prime, it will be 6 minus 4 is equal to 2. So it is positive. So the sign is going, or the derivative is down, then up. Down and up, which means the function f has a relative minimum at x equal to 2. F of x or only f, the function f has a relative minimum at the given point. At x equal to 2. And the value of the critical or of the relative minimum, this is will be equal to f of 2. If you replace x by 2 in the function, this one, I get 4 minus 4 is minus 4 plus 1 is minus 3 is equal to minus 3. So minus 3 is a relative minimum. Is the value of the function. F of 2, which is equal to minus 3, is a relative minimum. So this is the idea of finding relative maximum or relative minimum of a given function. I have to find the critical point first, then we need to test the sign of the derivative around the critical point. If it is positive and negative, then we have relative maximum. If it is negative and then positive, this will be relative minimum. And if there is no change in the sign of the derivative, then the function doesn't have any relative maximum or minimum at that point.